We're going to do a problem that deals with demand elasticity and its relation to tax revenues and deadweight loss. So here we are. This problem, they're going to levy a $30 tax per unit on suppliers of either genes or allergy medication. So the supply curve, it tells us, is the same for both markets. Here's the genes market. Here's the supply before the tax. Here's the supply after the tax. Now compare that to the medication market. Notice the supply curves are the same, okay? Which means if it's a $30 per unit tax, the supply curve is going to shift up by the amount of the tax. And we did this in class, but we can probably stand to do it again. So here we go. Let's look at the genes market. Now, for producers to continue to produce 300 units, they're going to have to net $30, okay? Because that's where the original equilibrium is. At $30, they're willing to produce 300. Now, if there's a $30 per unit tax, they're going to have to be able to get $60 at that price. Then they pay the $30 tax. That would bring them back to $30 where they were before. So that's what they would have to have. But of course, demanders aren't going to pay that. So the supply curve shifts up by the amount of the tax. And of course, the equilibrium now is here. Price of 35, output of 50. So in that case, if there's going to be 50 units produced now at a price of 35, and remember the vertical distance between the two supply curves is the amount of the tax. So tax revenue is collected would just be the amount of the tax. Well, it would be this distance here, 50, okay, 50 units, times this distance here, the amount of the tax. So $50 times a $30 tax, there's our tax revenue. So we're going to grab this tax revenue green thing here and put it where it will highlight the tax revenue. That area is tax revenue. Again, we've got the $50 there, base, times the height, $30, the tax, and that gives us the area of this rectangle. There you go. Now, it also wants us to show the deadweight loss. The deadweight loss, well, look, I mean, that's all the economic surplus that is lost that nobody gets, because output went from 300 all the way down to 50. And that's because demanders for this good are quite elastic. You can see by the slope of the demand curve that they're pretty flexible. It's pretty elastic compared to this curve we're going to do in a second. The medication is more inelastic or less elastic. And when you're really flexible or elastic, you can, you're not going to get taken to the cleaners by the tax. You're just going to stop buying the stuff, which is what they do in this example here. So all this area represents economic surplus that nobody gets. There's no consumer surplus. There's no producer surplus. Now, by the way, this part of economics is called welfare economics. Welfare economics is when you're analyzing economic surplus, deadweight loss, producer surplus, consumer surplus. So it's referred to as welfare economics. So how well off you are, okay, that's what surplus measures. Anyway, where are we? So deadweight loss. Let's fill that in. Maybe we should get some art credit for this class. A little bit. Okay, there you go. Lots of deadweight loss. Not a whole lot of tax revenue. And the reason they're not collecting a lot of tax revenue is because the demand is quite elastic. Now let's go down here and do the same thing. Okay, same thing exactly. Supply curve shifts up by the amount of the tax. We end up with an equilibrium here. So in this case, 200 units are being produced after the tax, 300 before the tax. And the difference between the two supply curves, vertical difference, is the tax. So we've got 200 times the amount of the tax, 30. There's the tax revenue. So let's fill that in. There you go. Base times height. Of course, base is the 200 units produced. Height is the amount of the tax, 30 units, difference between 20 and 50. And there's our tax revenue. Now they're going to ask for the revenue down here, tax revenue, and you just multiply that. I'm not going to do that. You can do that. And the deadweight loss. Well, that's this triangle here. That's the economic surplus that is lost. Lost to the world. It's like burned up in a fire because output goes from 300 down to 200. All the consumer surplus, producer surplus, poof, disappears. That's our deadweight loss. Now, as you can see, okay, look at the tax revenue. See that area of that rectangle? And the area of this one? So we can conclude that if you're going to tax something, you need to tax something that's relatively inelastic if you're going to get any tax revenue out of it. That's why cigarettes and booze and that sort of thing are popular to tax. They're inelastic and it's politically feasible because they're bad. You know, they call it the sin tax. If you tax medication, though, that's not as, I don't know, that's where this example goes astray. To my knowledge, it's not heavily taxed, but it's a good the economics works. The politics doesn't work. It's like taxing food. I mean, if you really wanted to get some tax revenues, tax food. A lot of places don't tax food at all, but food is pretty darn inelastic. But the politics doesn't work there. The economics works, but the politics doesn't work. So that's why you don't see food heavily taxed. Down here, they're going to ask you to calculate the deadweight loss. That's the only tricky part. And that is just the area of this triangle. And the area of a triangle is calculated as 1/2 base times the height. So, or easier, base times height times a half. So here's the base. It's a sideways triangle. Here's the base. Here's the height from here to here. So the height would be 50 to 300. So 300 minus 50, that's 250. So the height would be 250. The base would be 30. Multiply those, then times a half. There's your deadweight loss. And you'll be able to see with the elastic good, the deadweight loss. Okay, the tax revenues are smaller. The deadweight loss is much bigger. So here the deadweight loss is smaller. Okay, now that one, well, let's go back. Let's see if I can go back. Let me stop this thing for a second. Okay, I'm back. Here, I think this is the second one. And they have you do this before the tax thing, and you bring in find the equilibrium, then you do the consumer surplus, you do the producer surplus. and then they do a tax. Now on this one, they don't actually shift the curve up. Instead, they provide a wedge for you. Okay, this tax wedge is the difference. It's to do this the way we did it in class. Okay, here's the original equilibrium, and the tax is let's see, 15.35. Okay, the tax is 20, and we know that because that's where the new equilibrium is going to be. They don't. It's just set up a little differently. So here, shift up the curve by 20 bucks. Okay, this is 20. So this shifts up by 20 to 40. So if we were going to do this, if it would let us do this, we'd shift up the curve to there, and then the new curve comes through there. Okay, but they're just laying it out differently. I think it's easier to shift the curve, but there's our imaginary curve right there. And there's the new equilibrium. Okay, there's the new equilibrium. This is the difference between, this is the tax. And so we would set it up. Oh no, sorry, dead weight loss. They don't have a. They do that a little differently, but that's basically it. Everything else is the same. Imaginary shift up, then we have our new supply curve. There's our new equilibrium right there. Okay. So, if you have any questions, be sure to ask. But I think that from here, you should probably be able to be okay. All right. So we'll draw the line there, and been going for 12 minutes, probably snoring like a bear. So that'll do it for right now.